Hello everyone, my name is Isaque and I'm here today to talk about dynamic epistemic logic with assignments, concurrence, and communication actions. This is our agenda for today. And in this presentation we are going to talk about some epistemic logic, showing their difference, their usage. And since it's a short presentation, we are not going to go deep. If you want, please reach out to us or read our paper. The first logic that we are going to talk about is the multi-agent epistemic logic. That is the model logic used to represent and reason about agents' knowledge and beliefs. An epistemic model is a pair of a frame and evaluation function, whereas a frame is a tuple of a known set of states and a binary relation over these states. And this relation shows when the agent cannot distinguish two states. And the evaluation function is a function that maps for each proposition the states where this proposition is true. So let's go to our example. Suppose we have a card game with 3 cards, 0, 1, and 2, and 3 players, A, B, and C. And each player receives a card and does not know the other player's card. We use propositional symbols like 0x, 1x, and 2x. That means player X has the card 0 or 1 or 2. And we also label the states by the cards that the players are holding. So example, state 0, 1, 2 is the state where player A has the card 0, player B has the card 1, and player C has the card 2. So now we can model our epistemic model. We have 6 states because we have 3 players and 3 cards, and we can combine this and generate 6 states. And for example, we can see that player A cannot distinguish state 0, 1, 2 from the state 2, 0, 2, 1, because in both states player A has the 0 card, but player A does not have information about the other player's card, so he cannot distinguish these 2 states. And now imagine that player A wants to show her card to player B. This action of showing her card will result in a change of the player's knowledge. So how can we model this change of knowledge of the agents? Well, dynamic epistemic logic is conceived to reason about actions that change the agent's epistemic state. That is, actions that will change the agent's knowledge and beliefs. So to do this, they create an action model. And this action model is like an epistemic model, but for actions. And in this we have our finished set of action points that are the equivalent to the states. We have our equivalent relation over these action points. That means that the players cannot distinguish 2 action points. And you have the precondition. That is a function that tells us if we can or not perform this action point in the state from the epistemic model. So with this, now we can model this action of A showing her card to B. So A can show card 0, can show card 1, or can show card 2. Depends on the card that A is holding at her hand. So to show card 0, the precondition is that she has the card 0 at her hand. She cannot show if it's not the card that is in her hand. And from the point of view of C does not know which card player R is showing, but she can see that player R is showing the card to B. So after we perform this action, we have a new epistemic model that is the result of the Cartesian product of the old epistemic model with this action. And in this new model, we can see that player B has no doubts about the real state anymore. He knows that the real state is 0, 1, 2. But player A and player B doesn't know. They still cannot distinguish some states. And more, player C knows that player B knows which are the real states. And player A knows that player C knows that player B knows the real state. So you have high order information here that is very powerful. But now imagine that at the beginning, the dealer told the players that instead of 3 cards, you have 4 cards. But we are going only to use 3. And we are going to use the ones with values 0, 1, and 2. And the card 3 will be left out the game. But after distributing the card and the players already, we already modeled the epistemic model, the dealer realized that he made a mistake and left behind the card with value 2 instead of the card of value 3. So how can we perform an action to update this kind of information? Well, with dynamic epistemic logic, we can't, because we cannot change the value of the propositions. But with dynamic epistemic model, with assignments, we can assign new values to Boolean propositions. So to do this, they extend the concept of action model by adding a post condition. And this post condition means that after you execute this action, execute these new assignments. The post condition is a list of assignments that are going to be executed after the action. So now we can create an action model to do this, to update this with this information. So we have to remove the card 2 from the game and add the card 3. And that's what this action model is doing. And if we apply this action model in our previous epistemic model, we have this. We omitted the value of 2 since it's always false. So let's go back a little bit with the example with no assignments, because now we're going to talk about the dynamic epistemic logic with concurrency and communication actions, and this logic does not have assignments. But instead of a normal card game, because we are in a moment of isolation because of the COVID-19, we need to play this game online. So now the game is online, and the players can change messages between each other. So this new logic proposes a new type of action called communication action, that this communication action can be combined to form an action model. So from the point where they are combined and we create the action model forward, is the same as we said before. It's an action model and all the properties holds. So coming back to that example, now with this communication action, we can model that player A sends the message to players B and C, and the message P holds the information of the card that player A is holding. So with this, we can model this exchange of communication. But when you're going to execute, these communication actions are transformed into action models. So we are, from this point forward, we are executing action models. So now we are going to talk about the object of this presentation, of this paper, that is dynamic epistemic logic with assignments, concurrence, and communication actions. And why we are going to talk, we want to create a logic that can be can do assignments, can have concurrence and communication actions. Well, because in real life we need this. We have online games where people made mistakes, where we need to update an information, we need to update a proposition, and we cannot do this with the old one. We need to choose, or we have communication or we have assignments. So our approach is to add the assignment mechanisms from dynamic epistemic logic with assignment into the dynamic epistemic logic with concurrence and communication action, creating a new dynamic epistemic logic. So that's possible because both of these logics use action models and change action models in different points. So they are compatible. They are complementary logics. So we take the language from the dynamic epistemic logic with concurrence and communication, where they define this new action, communication actions, and combine this with the new definition of action model from dynamic epistemic logic with assignment, where they add this post condition function. In the paper, we present the axiomatization, show how to prove soundness, completeness, and decidability. And the proofs can be found in the full paper. Well, we show this. We show that we can combine these two logic. They are complementary. To do this, we add this postcondition to the action models of the dynamic epistemic model with concurrency and communication actions. And as a future work, we want to extend this to common knowledge that we left out because it's going to make the proofs harder, not impossible, but harder. We want to study more types of communications. And we want to create a model checker to deal with assignments, concurrence, and communication actions. And that's it. Thank you.